Good afternoon, everyone. So my name is Gabriel Ramirez. I'm the office lead here at Civil and Environmental Consultants at the Corpus Christi office. I have over 12 years of experience in the water and wastewater industry. During that time, I was able to earn the Class A water operator license and Class A wastewater treatment operator licenses from the Texas Commission on Environmental Quality. My master's degree is in environmental microbiology. And with me presenting today is my colleague, Lathika Varanasi. She's a project manager for CEC here in our Houston office, and she has her PhD in environmental engineering. We'll talk to you today about an exciting project that's going on that we're actively working on there in McMullen County to modernize the water and wastewater systems in both Calliham and Tilden. So here's an overview of the project that we're currently working on. On the wastewater side, we're working on the design of a conventional activated sludge packaged wastewater treatment plant that can treat about 20,000 gallons per day. Currently, they're discharging about 10,000 gallons per day, but we want to build it so that there's enough room for a little bit of expansion there. And of course, with Texas Commission on Environmental Quality, there's a 75% rule that if you get at that point, then you need to be working on the design for upgrading that wastewater treatment plant. So we should have some room to spare there. We're also going to be designing the relocation of the Calliham water treatment plant, which will modernize the water system as well. The third phase of the project is going to be doing a master plan for the Tilden water and wastewater systems. And this will improve operations and, of course, increase sustainability. First, we'll discuss case study 1, which is going to explain the Calliham packaged conventional activated sludge wastewater treatment plant. Then the case study 2 will be the modernization of the water system in Calliham. In case study 3, we'll talk about some of the potential upgrades for the water and wastewater systems in Tilden. At this point, I'll hand it over to Lathika to discuss case study number 1.
Thank you, Gabe. Good afternoon, everyone. So as mentioned, case study 1 is about designing a packaged wastewater treatment plant in Calliham. So there are 3 segments in this. One is there is an existing wet well on site, which will be converted to an influent lift station to convey water to the wastewater treatment plant. The second aspect is design and installation of the treatment plant, and it will be a conventional activated sludge plant. And the third part is discharge of the treated effluent into Salt Creek, which will convey the water to a public reservoir system. So the water will be treated to the level wherein it can eventually be distributed for public consumption. Yes. So this slide just shows the schematic of the influent lift station. So it essentially shows all the parameters that we considered in order to convert the wet well into an influent lift station. So eventually, the lift station will have 2 submersible pumps installed in them, and one pump will serve as a backup. And it will have control equipment, which essentially comprises of alarm systems to warn us in case there is any very low or very high flow. So just to ensure that the wet well is always at an optimum level for the water to be conveyed effectively. So this table just shows some of the parameters that were considered in designing the influent lift station. As I mentioned before, the lift station will comprise of duplay submersible grinder pumps. And we chose grinder pumps because the influent, which is the raw wastewater, is going to have a lot of solids, and we want to make sure that the solids are broken down and are effectively conveyed into the package treatment plant. And for that, we need a submersible pump and a grinder pump specifically. So some of the parameters considered was the minimum wet well volume that we need for the lift station, which was 21 cubic feet. We calculated the required wet well height to be 3 feet. And we also determined the total static head, which is the rise in pressure that will take place when the water is being conveyed. And to convey the water into the package treatment plant, we'll be using a force main, which is made of PVC. And these are the design parameters for the force main. We calculated the diameter, the design velocity, the total dynamic head. Again, the pressure that needs to be overcome for the water to be conveyed into the package plant, and the length of the force main. So what we've primarily determined is that the existing available height of 12 feet from the bottom of the wet well to the point where the water enters the wet well is more than enough for the wet well to be made into a lift station, because essentially the height that is required for the lift station is only 3 feet. And for the force main design, at this point, we've considered two 90-degree elbows to design the piping. So going into a few more details about the lift station. For the lift stations with submersible grinder pumps, it is acceptable if the force main diameter is less than 4 inches as per TCEQ regulations. And this exception comes into play only because we're dealing with high solids concentration in the water. And some of the advantages, sorry. Yes. So some of the advantages of using PVC as the force main design material is listed. They are corrosion resistant, low frictional loss. The pipes tend to last much longer, and the buildup of grease is relatively slow. And to determine the total dynamic head, which I talked about, that is to overcome the pressure, the primary calculation that was used is here. So the total dynamic head would account for the total static head, velocity head, and frictional head. These were the factors that were used in determining the total dynamic head. So moving on to the packaged wastewater treatment plant, as I mentioned before, this will be of a conventional activated sludge configuration. And in the table, the influent parameters that are listed here for BOD5, total suspended solids, and ammonia, these are the parameters that we determined after sampling the wastewater coming into Calliham, and these are the results. And the target effluent parameters is based on TCEQ regulations. So the design flow for the package plant, the average design flow is 20,000 gallons per day, and it has a maximum day flow of 86,400 gallons per day. So as I mentioned before, the treated water will be finally discharged into a public reservoir system. And since this is the case, the water will need to undergo enhanced secondary treatment with extended aeration, because the target effluent parameters, as you can see in the table, they're particularly stringent for ammonia, total suspended solids, and BOD5. And the sludge that is generated will be treated through sludge drying beds that will be included along with the conventional activated sludge unit to remove moisture from the sludge. And finally, the treated effluent will be discharged into Salt Creek. So this flow diagram shows the process layout, the sequence that will be followed in treating the wastewater. So we start with the influent lift station, which will firstly convey the water into the primary unit of the wastewater treatment plant, which will have a bar screen. Then it'll move on to a flow equalization tank, which is mainly to during days and seasons of very variable flow, the tank will help in equalizing the flow to make sure that it's uniform. Then it'll go on to extended aeration. And in parallel, there's a sludge holding tank to convey all the sludge that is generated when aeration is taking place. After aeration, it'll go through clarification, and then finally it'll be filtered once more through tertiary filtration. It'll be disinfected, and then the disinfected water will be aerated again once more to meet TCEQ's regulations for dissolved oxygen. And then finally, an effluent tank with pumps will convey the treated effluent into the creek. We also designed the sludge drying bed, and these are the primary calculations that we used to design the sludge drying bed. So based on the influent BOD parameter that we determined through sampling in the influent wastewater, we calculated the BOD loading. So that is dependent on the influent BOD5 concentration, the maximum day flow, and then there's a conversion factor associated with it. This helped us determine, and once we determined the influent BOD loading, we use that to determine the BOD population equivalent, which we need to finally determine the drying bed area for the package plant. So this segment looks at the effluent pump system that will convey the treated effluent into the creek. So again, the operational parameters are similar to what we looked at in the influent pump station. Once again, it will be a two-pump system. One pump will serve as backup. But in this case, it is just a submersible pump. There is no grinder component associated with the pump. The design flow for both the influent and the effluent pump will be 60 GPM, which is based on the maximum day flow of the wastewater treatment plant. And then we again have the calculations for the total static head and the operational parameters of the force main that will be associated with the effluent pump this time. So this has the diameter, the design velocity, and the total dynamic head, as well as the force main length. So here, the design velocity, we calculated to be 1.53 feet per second, which is lower than the generally accepted threshold velocity as per TCEQ regulations. That tends to be, the generally accepted threshold tends to be 3 feet per second. But although this is lower, the lack of solids in the effluent will enable the flow without any pressure fluctuation issues. So it is acceptable for the velocity to be less than 3 in this case. So the next case study, Gabe will cover it for you.
All right, thanks, Lathika. So case study 2 is going to be talking about the potential upgrades for the Calliham water treatment plant and the water system there. So we'll be designing a new water treatment plant in Calliham for the drinking water system. A new SCADA system, or Supervisory Control and Data Acquisition, is what SCADA stands for. That'll be set up to allow for more remote monitoring that can be done more adequately and be able to get alarms if there's any kind of system issues that are happening in real time. Then the operator could get out there and respond with the proper maintenance that's needed to maintain the system. We're also going to be designing a new well for construction there, an installation of a hydrogen sulfide system for odor control. That way, there's no type of nuisance from possible odors from the new water well. We'll also be adding a new well pump with the controls equipment and 2 new hot water storage tanks. So the groundwater in McMullen County could be around 150 degrees Fahrenheit. So it's coming out a little bit spicy there. So we need to have a hot water tank to be able to hold it. We're also going to be adding pumps for the transfer of the hot water to a new cooling tower. And the existing concrete ground storage tanks will also be demolished and replaced to store the cooled water after it's transferred from the cooling tower. Some other items that are going to be replaced and added to the new water treatment facility include the yard piping, the fittings, and the valves that are also going to be put in place. The new well site will also have new electrical equipment that will help to operate the associated infrastructure. The pressure relief valve in the pressure tank is also going to be replaced there. Additional items that are going to be added to the new treatment facility that are upgrades are the new sight glass of the pressure tank, replacement of the pressure tank equipment, and also replacement of distribution system pipelines. Now the next slide shows the site map. So there on the right, we have the current water treatment plant facility. And that's going to be all demolished and replaced and added to the new land that's going to be acquired by McMullen County. The new land is there to the left, and that's where the proposed new water treatment plant facility will be for Calliham. And that'll be located behind the cemetery. So once the existing water treatment plant is demolished, then the cemetery can expand that way. And the water treatment plant could be away behind there, behind where the cemetery is located on the new land that's being acquired by McMullen County. Now I'll hand it over to Lathika for case study number 3, which is going to discuss the potential upgrades for the Tilden water and wastewater systems. So the master plan for there.
Thanks, Gabe. So the next 2 to 3 slides pretty much summarize the potential system upgrades that we've considered both for the water and the wastewater treatment systems at Tilden. So we'll go over the wastewater treatment plant system upgrades first. So we determined that an installation of a fine screen system will be required at the very outset, as well as compacting and dewatering units for the sludge that will be generated. So the fine screen system will serve to remove grease from the influent lift station area, which will prevent any abrasion issues and will also enable ease of maintenance in the long term. And then other aspects to consider in the wastewater treatment plant would be evaluation of the influent lift station pump. And this will be done by gauging individual operational parameters such as pressure, flow, power draw to determine the current efficiency of pump operations. The other thing we considered was auditing the energy consumption of the existing 3 blowers to evaluate the blowers' energy usage and potentially optimize their operational energy consumption. Moving on to sludge, disposal of generated sludge from the wastewater treatment processes to a landfill is being considered for use as an alternative daily cover, and installation of a belt filter press system to dewater the sludge prior to its disposal to a landfill so that we ensure that the sludge is as dry as possible before it's being disposed. With respect to the Tilden water treatment plant, we're considering the installation of a new standpipe at the water distribution system so that the drinking water flows at a higher pressure. An alternative measure to this would be to increase the water pressure would be through the installation of an elevated storage tank. So this would serve as an alternative to the standpipe installation. Yes, that concludes our presentation, and we'll be happy to take questions.
Yep, and thanks to Travis and NRA for letting us present on this project today. It's an exciting project to upgrade the water and wastewater systems there at McMullen County again. And thank you for your time today, and we're ready to answer any questions that you may have for us.
Anybody have any questions for the audience before I have a few? Barbara?
What is the cost for a county that size to see a project like this? So many of us want to do these upgrades, both them, but worry about the cost. Can you tell us a little bit about the funding you have to tell us to try that?
Right, so the county has come up with their own funding system, their funding source that was provided from McMullen County. As far as the engineering costs, we do this job on a time and materials basis. So it'll vary on each component depending how long the process takes for it. With all three different phases together, we're looking at about $600,000 for the engineering services, in that range for the first three phases here for this project.
I'll speak a little bit to that. This is a great project. I really commend Judge Tilden, the commissioners there at McMullen County, and their staff, because these are unincorporated areas. So this is projects they're working on together between the community the leaders, the county, to get this project done. But they are going to be, majority of the funds are going to be coming out of their potential budget over the next couple of years. But this is just a really great example of how these small unincorporated areas and counties working together to get something like this done, a much, much needed improvements.
Oh yeah, definitely. It'll be a great improvement to modernize their wastewater and water systems. And of course, as y'all know, water is the lifeblood of the community. So it's going to be a great project once it's all said and done.
I know there was a little bit of talk during the water planning about population decline. I know that's a very hot topic we have whenever we speak about it all the time. But even McMullen County is growing. I know we were helping them with in the Calliham unit. I believe there were 3 new connections over the last just month or so. So people are moving to everywhere in Texas, including McMullen County. So it's great that they're thinking ahead before any of this other growth starts coming their way. Gabe, can you please speak to some of the timelines for the permitting and then your overall timelines for engineering and then construction?
Okay, sure. Yes. So the permitting process is underway. So we've read through of course, all the requirements for that. We're working with a couple of different vendors to finalize that process for the packaged wastewater treatment plant. Once that's completed, then we're going to, and a decision's made on a vendor, then we can fill out the application, turn it in. 330 days after that is when the plant can begin discharging effluent. So it's about less than a year process for the permitting timeline. The construction can happen as soon as TCEQ approves the discharge permit. So we'll have the designs and plans and specs turned in at the same time as the permit. That can be done concurrently. As soon as that's approved, then we can begin construction, and discharge again cannot start until 330 days after the permit. TPDES, or Texas Pollution Discharge Elimination System, wastewater discharge permit is turned in, so 330 days after that. And then on the water side, the land acquisition is happening in real time now. And so with that, as soon as that's finalized, we can work through the design process for relocating the water treatment facility in Calliham. And so the design for that should just take a few months. Of course, we have to turn it into TCEQ. The standard answer I usually get from them is 100-day return time. So, but I'm on it. We're going to follow up with them consistently throughout that process to make sure that it's nothing that gets delayed. And then the master plan for Tilden can also happen concurrently while the other projects are going on. And we brought on another engineer to our team that can help us out. Austin is back there in the back, Austin DeGaish. And so he can jump in and help us expedite this project even further now. So, yep.
Any other questions? Thank you.
Thanks, everyone.